Right. You up and running? Up and running. One. Let me go here. Okay. So we'll give them a few minutes to reach. Here, Josiah, here, Joel, here, Q, here. Khalifa, Leah. Page, yeah. All right, cool. That's everybody. So we will start and go from there with their bird. That's fine. All right. Hey, afternoon. How you doing? All right, folks. So let's continue from where we left off last week, Wednesday. So we started looking at how to factorize. Well, yeah, generally how to factorize, and we looked specifically at quadratic expressions. All right. So we did quite a few of them. So today we're going to see if we could just finish off the quadratics like this, and we actually saw how to solve a couple of them, right? And then we have some slightly different questions, including the last year question that apparently threw everybody because it was so hard, right? And we have a special case called difference of two squares that we'll take a look at as well. Okay, hold on, I'm not sure what all that blinking is about, right? All right, so we have some word problems, some other stuff. All right, cool. So we just have one or two more in this vein, and then we're gonna switch gears a little bit, right? Okay, cool. So this one here, right? So let's do both of these items now. Sorry about that. Right. So here, in this particular case, so hold on, let's see who the stuff a little bit. Good evening, how you doing? Hey Jaden, evening, how you doing? No starting, so you didn't miss anything. Right. Okay, cool. Huh? Israel. Yeah. 5 whole week. All right. And here's D'Angelo. All right, cool. All right, cool. There we go. Cool. Let's go again. Right. So if we were to factorize 5h squared and 12hg, so between 5 and 12, are there any any common factors between apart from 1? No, 5 is just 1 by 5, and 12 is 1 by 12, 2 by 6, and 3 by 4. So the only common factor is 1. So there's no common factor between 5 and 12. What about h squared and hg? H, right? Because h squared is actually what? H multiplied by h, right? And then the minus in 12 hg. So the common factor here is the h. Now when you pull out the h as the common factor, what goes in the bracket? 5h and 12g. Right? Because what are we actually doing? We're actually dividing each term by the common factor. Or if you write it out like this, like the product of its factors, you can kind of cancel out the common factor. Oh, try pretty. Yeah, that's good. Very good. Astro evening. Oh, bro, any crash courses for maths coming closer? Kinda, but not exactly. I'll let you know. All right. Now, what about the 2x squared minus x minus 6? We said this is a quadratic expression. And the key with factorizing this is splitting the middle term. Because if you look here, there's no common factor other than 1 for all three terms, right? A times c, very good. Well, basically what we want to do is we want to get this in a bracket like this, right? With with a term here, a term here, a term here, and a term here. And plus or minus here and plus or minus here, depending on certain factors, right? Sorry. Of course, I didn't bring any water. My lovely. Right. So as we know, the the coefficient of x squared we normally call a, the coefficient of x we normally refer to as b, and the constant term we call c. And what's the little trick we have to apply here? We have to multiply what by what? A by c, the coefficients, not the x's, just the numbers, right? So we're going to multiply 2 by minus 6. And what's 2 multiplied by minus 6? Good night. Minus 12, that's correct. Now, what we are then doing is we are looking for the factors of minus 12. Now, forget minus for a second. What are your factors of 12? We just said it just now on the top there. We have 1 by 12, 2 by 6, and 3 by 4. Now, because we have a negative product, right? Now, to get that negative product, we saw that we multiplied a positive by a negative. So the factors have different signs. One positive, one negative. So we know in each pair here, one has to be positive and one has to be negative. How do we know which one? Whatever sign B has, right? So that B is actually minus 1, right? Where no number is explicit in front of the algebraic term, 1 is understood, right? But it does not mean that x equal to 1. I had that. Somebody tell me it's like one person every time. They say, so isn't x 1? I'm like, no. So you're sure? Yes. We're doing this sometime now. X is not equal to 1. Not all the time. Sometimes, yeah, but there's a 1 in front of it. I don't know if that's what the person meant, but I think they thought every time they saw x, it was equal to 1. So, no. All right. Shy pretty. Yes, that's correct. That's correct. And K. Very good. Yeah, I do maths and I have maths. Right. So, from here now, if this is negative, the larger factor in each pair is negative. So, which of these pairs here, when we add or subtract, will give us the minus 1? Well, 1 minus 12 is minus 11. 2 minus 6 is minus 4. And 3 minus 4, that's minus 1. Right? So minus 11, minus 4, minus 1. So this, right? So what do we do with that? Well, what we do is we use these here as coefficients of x to do what I call splitting the middle term. So what that means is that we're going to rewrite minus 1 as minus 4x plus 3x. Now, it doesn't matter if you put plus 3x in front and minus 4x behind. It's just that certain arrangements make it easier to facilitate the factorization that comes after, right? Like, for example, here, now that we've split minus 1x into minus 4x plus 3x, we could factorize each pair of terms by grouping. So between 2x squared and 4x, so between 2 and 4, what's the highest common factor? 2. Between x squared and x, what power is this x understood as being raised to? 1, right? And the highest common factor is always the lowest power. So we pull out x to the 1. So when we divide, 2 divided by 2 is 1, and x squared divided by x will give us back x. When we divide this by 2x now, 4 divided by 2 will give us back 2, and x divided by x is 1. Right. Sorry. Now, between 3x and minus 6, well, there's no common algebraic term. Only 3x has an algebraic term, minus 6 is a constant. But what about 3 and 6? Is there a common factor between 3 and 6? 3. 3 is 1 by 3, and 6 is 2 by 3. The common factor is 3. Right? Now, if you're wondering whether to make the common factor positive or negative, the little rule of thumb I use is whatever sign this has, use that same sign. Let me show you why. If we divide 3x by 3, if you want to see it, 3x divided by 3, the 3 will cancel, leaving us with just x, not so? And if we did minus 6 divided by 3, a minus divided by a plus is a minus, and 6 divided by 3 is 2. So you'll get minus 2 in the bracket here. Now, why is that important? Because we need these two brackets to be the same. Because guess what we're going to do? We're going to factorize again. But instead of using a single term, whether it's an algebraic term or just a constant as a factor, we're going to use the whole bracket as the common factor. When you pull that out now, basically all that happens is the coefficients are collected in a bracket in the back. So you pull out the common factor and you put the uncommon factors to the back. And this here now is the factorized form. Whether you state it as x minus 2 by 2x plus 3, or whether you do 2x plus 3 multiplied by x minus 2, it matters not. Because as we know, if we're multiplying, multiplication is commutative. The sequence of the multiplication doesn't matter to the answer. 2 by 3 is the same as 3 by 2. All right? All right, so just to recap, right? When you are given a quadratic expression to factorize, you multiply the coefficient of the x squared term by the constant. You get a product. We are then looking for the factors of that product that will add back to give us the middle term. Right? So remember, remember what I said. There's another way you could work this, right? Sorry. Right. So the other way you could work it is a little more of a brain teaser, if that's your sort of thing. But let me explain. I'm not trying to poison you against it by that particular word, right? Right. So we should be able at this stage to recognize this as a quadratic expression. And we should know that it would factorize the 2 binomial. It usually can, right? It's very, very rare for them to bring a quadratic expression in a math CSEC exam that can't factorize, right? If it can't, then they usually tell you solve it using the formula, which we'll get into a bit later, right? Right? How do I get the minus 1? The minus 1 is understood. So minus x is understood as minus 1x, all right? Right? So if there's no coefficient explicit in front of the algebraic term, 1 is understood. Hey, Daryl, thank you. Right, okay, cool. Right, now check this, right? If we know that this is going to factor into 2 brackets, right? And the first term has to be the x term, right? So x by x will give us x squared, right? But is this just x squared or is it 2x squared? 2. Now, we therefore need to put numbers in front of here that when you multiply will give us 2. But the good part about 2 is that 2 only has 2 factors. What numbers multiply to give us 2? 1 and 2, right? It makes it what kind of number? A prime number. What's a prime number? A number that has only 2 distinct factors, 1 and itself. So 2. 2 actually is the first prime number, right? And it's also the only even prime number. All other even numbers are divisible by 2. That's the definition of being an even number, being perfectly divisible by 2, right? So no other prime numbers are even, right? The next, what's the number after 2? 3. What are your factors of 3? What numbers multiply to give us 3? 1 and 3, which makes 3 a prime number as well. What about 4? 1 by 4, but also 2 by 2. So is 4 prime or not prime? It's not prime. If a number is not prime, it's called composite. What about 5? 1 by 5. Any other factors? No. So 5 is also a prime number. It also has the distinction of being the only prime number ending in a 5. Because all other numbers ending in a 5 are automatically divisible by 5. Right? Anyhow, before I go into also the number theory that I don't even know. Long story short, if we're looking for 2 numbers to multiply to give us 2, we only have 2 options. 2 and 1. But of course, we do have to write a 1 here because 1 is understood. So if you multiply 2x by x, do we get 2x squared? Wasn't that your question? Right? If you multiply 2x by x, so 2x is equal to 2 by x. So what power are these x's understood? Power of 1, right? And when you multiply and you have the same base, what do we do with the powers? We have to add the powers. What's 1 plus 1? 2. Right? Okay, so we know that 2x squared gives us back, that 2x by x will give us back x squared. Now what about the 6? So the 6, the numbers behind here have to give us the 6. What are our possible options? We're either going to have 1 by 6 or 3 by 4, right? Now it gets a little more complicated when we have a coefficient other than 1 here, right? But we also know something. We also know that this is negative, not so? To get a negative number when you're multiplying 2 numbers, you have to have 1 positive and 1 negative. If they were both positive, we will get a positive number. If they were both negative, we get a positive number, right? A plus by a plus is a plus. A minus by a minus is also a plus. The only way to get a minus when you multiply 2 terms is to multiply terms of different polarities, different signs, 1 positive and 1 negative. So, but the thing is, we don't have to put the plus here or the minus here or vice versa, right? So that's where it gets a little tricky. That's why I said this is a little more of a brain teaser, right? Now, if you were to put 1 and 6, right? And you put a plus here and a minus here. If you multiply 2 by 6, what do you get? 12. If you multiply 1 by x, you get 1. So you end up with minus 12 and positive 1. Will that give us back minus 1 in the middle here? No. Right? So 1 and 6 probably not going to work. What about 3 and 4? That's the only other pair, right? So let's put the not 3 and 4. 2 and 3, right? If we put the 2 here and the 3 here, right? Does that work? 2 by minus 2 is what? That's minus 4. And 3 by 1 is what? Plus 3. What's minus 4 plus 3? Minus 1. So that's the correct answer. Right? Now, like I said, this way is a little more cerebral. It requires a little more manipulating, a little more mental maths. Right? So that's why this particular way here is usually the way of choice for CSEC maths. But it's not to say you can't experiment with this. At this stage, with the exam being next week, Friday, right, you mightn't want to experiment too much. You might want to stick with something that works and refine it. All right? But it's always nice to have something in your back pocket should you need something. So do I have a recommended channel for HSB? Nah, boy, I don't know anybody. On TikTok, if you want, actually, that's where you are. I've seen lots of people recommending TikTok or YouTube channels to study for the CSEC. I'm not sure what the hashtag is, but you could check. You could put like CSEC YouTube channel or something. Not sure. Anyhow. All right. Yeah. So that's that one there. Now, with that said, again, like I said, I still recommend this particular method because it's a little more straightforward. All right. Hold on. We did this one already? Yeah. Okay. So, that's the same one. Okay, so guess what? We kind of ran out of quadratics to fact. Okay, we have one more. Okay, that 378 real big. I'm going to give you all 370 to factorize. Look at that. Okay, yeah, so I think we did all. Yeah, even this number 225 is too big. So that when the numbers get too big, I would tell you use the formula. It's just more efficient. Oh, all right. All right, so you all want to work? Just to kind of warm the brains up? All right, cool. So try that one for me. So factorize it first of all, and then we'll talk about something. Any paper? All right, cool. On accounting principles, not really. I'll tell you why. Because it is a lot. I just kind of answered the possible questions. So, not sure how to advise you on that one, boy. Yeah, the coefficient of this x is 1 for sure. Yeah, that's a 1 there as well. That's correct. Yeah, so yeah, x squared plus x minus 72. Right, so don't worry with the equal to 0 just yet. Right, we'll put that in after. Evening, Julia. How you doing? Good to have you on. Right, yeah, we're doing some quadratics tonight, Julie. So can you circle theorem? I did that already. I might do a revision of it next week. After tonight, we just have Wednesday, and then we're taking a break and just focusing on POA for the rest of the week. And then after the POA exam from Tuesday, so Tuesday we're doing 2 sessions, 4 to 6, half 6 to half 8, and then Wednesday and Thursday we're doing like from 10 in the morning till like 9 in the night, with breaks in between, of course. Circle theorem will probably make an appearance there. But you can check my channel, and see if you see any lives. I should have some lives there that might help you. I should. If not, let me know. I'll see if I can make some of it. Maybe live on TikTok too, Lumic. Yeah, once I live on YouTube, I live here as well. Usually. YouTube recording is the recording that's given to my classes, and TikTok stream is the backup recording. Because there was sometimes the YouTube recording did not record, and TikTok's kind of saved my life there. Sorry. doing a period live. Yeah. Yeah. That Monday is chock for his English first and Spanish after. That's in the actual exams. So yeah. I would have liked to have started 1 o'clock, but 4 o'clock most likely. 4 to 6 and then half 6 to half 8. That is it. That session is probably already booked for reissue. We'll see how it goes now. No problem. All right, cool. All right, so let's get the numbers going here. So what's the number understood in front of the x squared? Wait, you need a minute again? Yeah? All right, okay, good. Oh. All right. All right. So the number in front of the x squared is understood as 1 and sending for the x, right? So when no number is explicit in front of the algebra, 1 is understood. All right, so the value of A is 1, value of B is 1, value of C is minus 72. All right. This one is actually kind of easier to solve with the kind of, I don't want to say the guessing game, but let's do the proper way first, right? So we're going to multiply A by C, which is 1 by minus 72, which just gives us minus 72. So what we are looking for are the factors of minus 72. So start off with 1. So forgetting minus for now, just go with the number itself. So you have 1 by 72. Right? It ends in a 2, so it's even. So you could use the calculator, 2 by 36. It adds to 9, so it's divisible by 3. So that's 3 by 24. That's 4 by 18, 5, no. 6 by 12, and then 8 by 9. Now, it's a negative product, which means in each pair of factors, one is negative, one is positive. How do we know which one is which? Whatever sign that has, the larger factor has the same sign, which means by default, the smaller factor has the opposite sign. So which of these pairs differ by 1? The last pair, minus 8 and 9. And that's how we split the middle term. So we split this, right? So 1x could be written as 9x minus 8x. Right? Now you don't have to put the 9 in the front. You can put the minus 8 in front and 9 to the back. It doesn't matter. Now we then factorize by grouping. Between x squared and 9x, x is the common factor. And when we divide or factorize, right, you're going to get in the bracket x plus 9. Right? If you want a little more meat for that, basically what you're doing is you're considering x squared as x multiplied by x. And you're considering 9x as 9 multiplied by x. If you look at it, they both have a common factor of x. So if you take that out, what's left? X plus 9. All right, similarly with minus 8 and x, right? You have minus 8 by x, and then 72 could be, as we saw, minus 8 by 9, right? If you take out your minus 8, you're left with this x plus 9. So take out your minus 8, you're going to have x plus 9. Now, once you can see that the two brackets are the same, the bracket now becomes the common factor. So you pull the bracket, x plus 9, and you put the coefficients of each bracket in a bracket to the back. right? Okay, now it started off by saying it was equal to 0, right? So if, as in what, x minus 8 and x plus 9? Right, so if you do, if your minus is the bigger one, it means that this would be negative, right? Yeah, so yeah, that's what she signs. But you had the right numbers, 8 and 9, right? How do you find the factors for larger numbers? I would just pick it apart using prime numbers. I could show you. Let me show you this one as an example, right? Like here, I had the 1 and the 72, right? So now it's 72, so you know it even. So you could take your calculator and divide. 72 divided by 2 will give us 2 by 36. Now 36, we know is 3 by 12, right? So then 3 by 12. So then what you could do, you could rearrange this and put 3 in the front and 2 by 12 here. So that will give us 3 by 24, right? Now that alone, that's also 3 by 8. So you could pull that and get 9 by 8 or 8 by 9, right? But again, what I would suggest is after you pull it apart to the 2 by 36, right? You get 2 by 3 by 12. That's 2 by 3 by 3 by 4. But that 4 is actually, you bring it here, and you have 3 by 3. So that 4 is actually 2 squared. The 3 by 3 is 3 squared. And you have 2 cubed by 3 squared. So then now you had to kind of rearrange that into different combinations to get all the factors. But long story short, I would say use your calculator. So will you be doing the part where you find the points and intercepts to sketch on your own graph maximum? That's a different class. But I will, because as like question 8. So that's on the agenda for next week for sure. Right. Sorry. So coming back here now. So if going back to the original thing, we have x squared plus x minus 72 is equal to 0, right? So if we have that, right, and we just factored this expression like that, so we could put x minus 8 in the front, x plus 9 to the back. Doesn't matter because we're multiplying. And as we said earlier, multiplication is commutative. So it doesn't matter which one you put first once you multiply. Now, here we have an interesting statement. We're multiplying two things and we get 0. The only way to multiply and get 0 as the answer is to multiply by 0, right? So we have to, because x is variable, the value of x can change. We say, okay, either x minus 8 is 0, or it's possible that the next factor, x plus 9, is 0. So if this is 0, 0 by that will give us 0. If this is 0, multiplying by 0 will give us 0. So if x minus 8 is 0, and you carry over the x and change the sign, which is not the best way to explain it, you get 8. If x plus 9 is 0, x is equal to minus 9, right? Zana, after today, Wednesday, and after this Wednesday, it'll be next week, Tuesday. Wednesday and Thursday, next week. Wednesday and Thursday would be like from 10 in the morning to like 9 in the night. Probably like half 8. I had a game for now. Right. So yeah. Okay. All right. All right. Now, like I said, we don't actually have any more questions to factorize full quadratics, so we did all between last week and today. But what we do have is we have this item here, but I wouldn't start with that one, right? Good. No. I'm gonna find the one I want to start with. There's none of these. Okay, let's start with this one. Okay. All right, so this is Jan 2015. So this is m squared. Hold on, let me actually increase the weight on that point. Right, so hold on. Do I have 100? I do. Okay, cool. So we have m squared minus 4n squared. Let's make it a little simpler for now, right? M squared minus n squared. So you might be saying, okay, so we can factorize this. It have no common factors. I'm going to show you something interesting. Let's see. Sorry. Could you stop your dotishness? Thanks. Right. Let's say I give you this. Let's say I give you x plus 3 multiplied by x minus 3, right? So let's expand and see what we get, because we have two brackets, so we're supposed to get a quadratic. We're supposed to get an x squared term, then an x term, then a constant, right? Okay. Let's expand. X by x will give us what? X squared. X by minus 3 will give us minus 3x. 3 by x will also give us 3x. And 3 by minus 3 will give us minus 9, because a plus by a minus is a minus, not so? Right. But look at the terms in the middle. You have minus 3x plus 3x, which can be written as 3x minus 3x. What will that simplify to? What's 3x minus 3x? 0. If you subtract something from itself, you have nothing left, right? 3 minus 3 is 0. 3x minus 3x is 0. Which means that the middle term is now 0. So you have like x squared minus 0x minus 9. But 0 by x is what? 0. But if we were to write x squared minus 0 minus 9, couldn't we just as easily write x squared minus 9? Yeah. So here we have, this is actually a quadratic expression. Unlike the previous quadratic expressions, there is no middle term, no term in x. There's just the first term, right? The x squared term, and the constant. But what we know about this, x squared is literally the square of x, not so? What about 9? Is 9 also a square? What squared is 9? What? 3, right? So you could also write this as 3 squared, right? So we literally call this the difference of two squares, because you're minusing one squared term from another squared term, right? So this is called the difference of two squares. Right? So if we get two terms, first, and we've seen an explicit square there, and there's a minus in the middle, right? So if you break it down, difference of two squares, difference means minus it, right? 2 literally means two terms. A square means the power of 2, right? So here, difference, are we subtracting? Yes. Do we have 2 and only 2 terms? Yes. Are they both square terms? Yes. So all we have to do here is as follows. We open 2 sets of brackets. You find the square root of the first term. What's the square root of m squared? Just m, right? And you put it first. Right. Oh, I see some comments. Right. Any more crash courses for one? That's nice. Good night. Good night. Right. Right. John paper harder. Stick to me, June. Yeah, it depends. It depends. But that's not like a hard and fast rule. Right. Sorry. So after you find the square root of the first term, you put it first in the bracket. Then you find the square root of the second term. What's the square root of n squared? N, right? And then to cap it off, you put a plus in one bracket and a minus in the next one, right? You can put the minus in the front and the plus behind. It doesn't matter. Why? Because we're multiplying, and multiplication is commutative, right? Whether you multiply a by b or b by a. Yeah, Brandon, no problem. That's cool. What was that, sir? Right. No. I took that as an easier version to do, right? So now, right, let's bring back the original thing, which is m squared minus 4n squared, right? Right. So if we consider m squared minus 4n squared, so difference of two squares. So difference, are we subtracting? Yes. Is it 2 and only 2 terms? Yes. Are they squares? Are they perfect squares? As in, if you were to find the square root here, what's the square root of m squared? Just m, right? So you could rewrite m squared as just, well, m in a bracket and a square on the outside. What about 4n squared? Is 4, yeah, if it's square root 4, what do you get? 2. And if it's square root n squared, you get n, right? So once you could express it like that, then you can write the answer quite simply. For the m first, the 2n second, a plus in one bracket, and a minus in the next one. I'll give you a couple of seconds to just copy that down. Hey, Chris, what vibes? Yes, okay, cool. No problem. All right. Tomorrow. Right, Google Meet. I didn't ask you some stuff for a while, so sorry about that. If you guys are good with what I've explained with the difference of two squares, give me a quick junior chat now, please. Sorry, I know I'm not asking. All right, cool. You're doing something, that's good. Okay, how are we feeling with that one, guys? Okay, so what we're gonna do, we're just gonna go through all the questions and do all of those, and then we're gonna see that should take us about maybe 30, 40 minutes at most. And then from there, we will do some of these slightly harder ones. And if anything is across the Wednesday, then so be it. Now, again, just to remind you, oh crap, I'll close the just now, give me 1 second. All right, Wednesday is the last regular session. All right. After Wednesday, we're going to take a break because POA is on Tuesday. So I'm going to focus on my POA students, right, to cram in their sessions this weekend here. Right. So we are here Monday, right? Now, after POA is done, right, on Tuesday, we meet 4 o'clock, right? If anybody wants to come early, let me know. I'll see if I can start at 1, right? And as you can see, I kind of booked out all of Wednesday and Thursday, right? Normally I would have started at 8, but I'm not so wicked, right? If anybody has any of these exams, I obviously expect you all to go and deal with that. I don't expect you all to sacrifice those things for maths, right? So if you all have any of these, please go and study for them. And then after the or you know, see something I wasn't sure about. Oh, it's a good thing I pull it up. Well, boy. Figure it out, right? None of these are mandatory for anybody because, again, like I said, this is your exam season. You have to decide what you're going to do, right? Um, so I'm not forcing anybody to come at any particular time that don't work for you, or if you have another exam to study for, I understand. All right. I will be here to facilitate. If nobody come in, I would like to know, so I'm not here sitting down doing nothing. Right? Okay. Let's. Which one? Yeah. Yeah. Because like I say, 4. Yeah. 48, yeah. Right. And most likely, like I said, I'm gonna pull some topics like the statistics. People have been asking for it, so I might do it. Right. So statistics, circle geometry might make an appearance on the Thursday, and then in the evening we might do well, they're doing functions now, so I might do that with you all. And then I want to work on some of the question 8, which is like distance, speed, time, completing the square. And then, well, I might finish off with bearings, but I'm not sure. Right, we'll see. Anyhow, right, guys. So let's get back to the algebra. Okay, the multiple choice. Okay, so that multiple choice is the last exam right here, right? So obviously English A is the day before. It have Geo, it have TD, it have Bio and AdMath, HSB, French and Chem, right? So I could start the weekend before, right? AdMath is the Tuesday, but Mishka can kind of handle the AdMath unless she can't make it, then I will take it over, right? So yeah, right? Yeah, well, because they have other exams in between, right? Yeah. I had a start my phone force back at some point, otherwise they will leave me. And then when all they're going, I have nobody, so it will be a pressure. Right? So yeah, so multiple choice will get done. Right? I could kick these people out here, because they'll have time next week. So we could probably do like 8 or 9 sessions depending on what all you're available for. Because yeah, I know some of y'all have TD and GO and things. So anyhow, we go figure it out. Okay, cool. So let me start from the top here. Just to show you, right? This one, if you pull out the A, you get A squared minus 12. Now I'll show you a trick here. This is not something you're supposed to know how to do, right? But I'll show you anyway. So remember how I said, what's the square root of A squared? A, right? Now this is a special hack. If you ever find yourself, you could use this hack, right? Where? Where? Yeah, it was A cubed first, right? So what I did was I pulled out the A. Now is it right? But the thing is, 12 is not a perfect square root, right? But this is the trick. I'm going to show you a trick you could use, right? Now, again, this is not really something you're supposed to know how to do, but I've seen them bring something like it on exams before. So I'm just showing you, right? So the square root, so you could also write this as just A squared, right? Okay. What's the square root of 12? Anybody know offhand? 3.464101615. Cool. Anyhow, or you could simply write it as the square root of 12, not so? That's not what I asked you. What's the square root of 12? Just that, right? And you can put a square sign. So the square will cancel the square root. So technically speaking, you could turn anything like this into a difference of two squares. Even if you have, let's just say x minus 3. You could turn that into root x plus root 3 by root x minus root 3. Now, again, that's not something that you all should have to know how to do. You probably don't need to know it, but just in case, all right? So that first one, that's just a kind of jumpy one. I'm just showing you something. You don't have to know it. I'm just showing you. All right? Don't panic yourself. Don't start to get frightened and put up the list. Right, next. This one. So let's run the cross checks, right? So we have 4a squared minus 16. So difference of two squares. Are we subtracting? Are we finding the difference? Sorry, hey, look on the phone, reach boy. Hold on 1 second. Hey, evening, Hanifa, how you doing? Yeah, we still doing some factorization here. But let's mark your present. All right. No props. Who me? Real life, yeah. Bank recs, yeah, today. You can see it on my channel. When is the stream ending? In about 40 minutes. 8:30. It might end slightly earlier, but we'll see. Right. You're good? Okay, cool. Right. So check it. Difference of two squares. Difference. Are we subtracting? Yes. Do we have two and only two terms? Yes. Are they squares? Are they perfect squares? If you were to find the square root of 4, you'll get 2. Square root of a squared is just a. So 4a squared is the same as the square of 2a. What about 16? 4. So how would you write this? Plus 4, and then? Right. Now, what is this instruction here? Completely. If you were to do this, you would not have factorized completely. Because between 2a and 4, there is another factor. 2. So you can pull out 2 from the first bracket and get a plus 2. And you can pull out 2 from the second bracket and get a minus 2. And when they multiply 2 by 2, guess what you're going to get? 4. So you get 4 by a plus 2 by a minus 2. And the other way we could have seen this is at the very start. Between 4a squared and 16, we could have pulled out the 4 first. If you pull out the 4 and divide, you get a squared minus 4. And look at a squared minus 4. That's the difference of two squares, right? A squared is literally the square of a. What about 4 squared? That is the square of 2. And from here, we got to factorize as inside the bracket a minus 2 by a plus 2. So when you're checking it out, don't rush right away to factorize as is. Look at your instruction. If your instruction just said to factorize, then we could. This is a good answer, right? That is a correct answer. If you said factorize completely and you stopped here, you would not get all of your marks. Sorry, Zana. Yeah, a by a squared minus 12 is the correct answer they're looking for there, Zana. Sorry, I don't see your question. Right, the other one is just me being extra. All right. Right, so yeah. So if they say factorize completely, see if there's a way to factorize the first pair the terms as they are. If not, like if it was just a squared minus 4, then you can't factorize that initially. You could just go straight to the difference of two squares. All right, okay. I'll give you a couple of seconds if you're copying anything down. Let me just check my massages. Okay, go again. All right. This one here, 4m squared minus 1. Difference of two squares. Difference. Are we subtracting? Yeah. 2 only two terms? Yeah. 4m squared, is that a square? What you get? You get 2m. Is 1 a square? Yes, because 1 squared is 1. All right. Factorize that. Let me see what you get. Yeah, what we got? All right, 2m minus 1 by 2m plus 1. All right, cool. All right, Google Meet. You must give a quick G in the chat if you go with that one. Please sometimes. I know it's easy stuff, but let me just make sure we're good. All right. Ladies, be okay with that? All right, Zia, how we feeling with that one? All right, let me go again. All right, what about that first one? Difference. Are we subtracting? Yeah. Two terms and only two terms. Yeah. Are they both squares? One is 1 squared. What about 4h squared? Correct. All right, factorize it. 1. All right, so what do we get there? 1 plus, and then 1 minus. All right, cool. All right, going again. 22, nothing. 23, 1. That's a different type of question. 24, 24 was a serious step. Okay, we started with this one. Where are we going? Aha, factorize completely. What are those terms? Right, okay, as the words, what are the terms? What are these terms? Just what are they? Read them out for me. Right. So are there any common factors right now? 4. So pull out the 4 first. Pull out the 4 first, and then the brackets, see where you get. Right? Or it should still be a difference of 2 squares. Take out the 2's. Who me? Which one? From here? From this particular question? Who me or from a previous one? There's a bit of a delay with the YouTube. It's like about 6 to 8 seconds when I do it, and like when you all see it. So I had to go back and let them know. If you take out the 4, goes in the bracket. X squared minus 1. Because we divide. When we divide 4x squared by 4, it'll cancel, leaving us with x squared. And then when you divide 4 by 4, you get 1. Now, in the bracket, is x squared minus 1 still difference of 2 squares? Yeah, because we're subtracting 2 and only 2 terms, and they're each square terms. So what we'll get here is x plus 1 by x minus 1. Or x minus 1 by x plus 1. All right. Jada Marie. Hey, how you doing, Jada Marie? I had a Jade Marie in my class 11 years ago. Actually, she got married. She had a baby recently too. Bumps up in price now. Sorry. All right, cool. Going again. That first item there. No. Does the positive bracket have to go first? No, you could do x minus 1 by x plus 1 because we're multiplying, it's commutative. That means that it doesn't matter. Like 2 by 3 is the same as 3 by 2. Right? Foundation Z979H. Right. So this is actually Caribbean exams, which is CSEC, Caribbean Secondary Education Certificate, but we are descended from the British. So our stuff is based on the GCE syllabus. Yes. There may be some variations here and there, but quadratics is definitely there. So it would help as well. But I saw a couple of very interesting GCSE maths. The next one, the name I can't exactly say out loud. Right. So are we finding the difference of 2 terms? Yeah. X squared minus 36. Are those 2 terms both squares? Yeah. X squared is the square of x, and 36 is the square of 6. Right. So this is the square of x minus the square of 6. So when you factor it, you're going to get x minus 6 by x plus 6. Right. Or x plus 6 by x minus 6. They both mean both versions are the same. Mean the same thing. 33. What? But to do that, you'd have to factor. Remember, you have to factor within the bracket. You can't factor between the brackets. Right? The brackets cannot close off each pair from the other. So you end up having to factor in each bracket one at a time. But this is O level, so this would be equivalent to your IGCSE. It's not that same syllabus, but this is an overlap, but it's O level. All right, Google Meet, you know the drill. If you're good with that, give me a Genie chat, please and thanks. All right, lovely, thank you. All right, one. Aha, all right. So now we're getting interested. In this first one here, we have x by y. So we have x multiplied by y minus y squared, which is y multiplied by y, right? Between these two terms, are there any common factors? Y. So if you pull out the y, what goes in the bracket? X minus y. Cool. Now, I want you all to factorize this one for me. Right? That should be a relatively easy one to factorize. Oh, okay, right. C9. Right. Yeah, okay, good, good, good. Okay, so when we factorize the one below, what do we get? Plus y. See, is it difference of two squares? Are we finding the difference of two terms? Are we subtracting one term from our next? Subtracting, it's two and only two terms, and they're both squares. All right. So now check this. When they ask us to simplify this expression down here, right? Now, when they say hence, usually that's a clue. It means they want you to use what you got in the previous parts of the question. So if this numerator here is the same as this term, so they probably want us to use the factored form. So when you factor to get y by x minus y, the denominator is part b. So x squared minus y squared will give us x plus y by x minus y. Now, guess what happens? We could cancel this with that. And our final answer would be x over x plus y. And you cannot cancel these. So please don't do that. Right? That's like me telling you, okay, if you put 2 over 5, you could rewrite 5 as 3 plus 2, not so? And then you could cancel this. So that's equal to 1/3. Is 2/5 equal to 1/3? No. So you cannot cancel if you have addition and or subtraction in the numerator and denominator. There's a specific way to do it, but you have to cancel like the entire bracket. All right? Right, IDK, but the GIs, I don't know. Okay, Mekai Estrada, yes. Are you the same Mekai who messaged me? Do I teach further maths? I would love to teach further maths. But first I had to do further maths. I did maths at A levels, but there wasn't. So back in the day when I did it, this is, I'm talking about 2000, so 25 years ago, right? It was maths and further maths, but I didn't check further maths. I actually took maths as an extra A level subject. I was doing econ, accounts, and MOB, and I took up maths as an extra A level subject. Did better than maths and econ. And actually came first in my school that year with the accounts and the M. All right. Okay. Yeah, folks, are you all okay with this question? Google Meet, if you're good with what I just did, just give me a quick G. All right. Zana, I don't do physics, but I have someone working with me who does. She has a first degree in physics, a master's, and is doing a doctorate currently. Zayden, yes, we're doing multiple past papers, but we're picking just the factorization. All right, cool. Okay, so if you're okay with that, we're doing this one, right? So this is x squared minus 49, right? And what I will do is I'll take out, oops, I'll take out this, right? So here, this is Jan 2025. This is the most recent exam, right? Factorize each of the following algebraic expressions. So you have x squared minus 49, and then x squared plus 2x minus 35, and then hence simplify this. So that means they want you to do what you just did in the previous question, right? They want you to factorize this, and then use those factorized forms as numerator and denominator, see what could cancel. All right, so I'll give you all a few minutes, right? So you have a difference of two squares, you have a regular quadratic, and then you have to divide. All right, so while you're all doing that, I just take a walk across for the next half of the class. Right, so if any questions come in, I don't answer right away, don't feel how. Did I just see Mr. and Mrs. James? Good evening. Condolences. Right. Wishing you all the best. What time I come in? Seven nine each. Yes. Actually, hold on. Check that one again. X minus 7 will actually cancel. No, the x plus 7 will. So you're left with x minus 7 on top here. What about below? All right, give me 2 minutes. Means they're not complex numbers. All right, yeah, guys. Sorry, back on the inside. Rebecca. Hi, how are you, Rebecca? Good to see you. Okay. Yeah. Um, what? I was pooping. Great, thanks. Hello, won't come. He wake up late, so they had a. Well, I had no way to watch him, so hard luck. Okay, so when we factor x squared minus 49, so is that difference of two squares? Are we subtracting? Is there a difference? Yes. Is it two and only two terms? Yes. Are they each a perfect square? Yeah. Because x squared is literally the square of x, right? 49 is the square of 7. And you put a plus in one bracket and a minus in the next one. All right? Whether you put the minus or plus in the first bracket and vice versa. Right. What level is this? C-Sec. This is O level, so C-Sec or GCSE. Thank you, yes. Right. For this one now, I'll do the short way. So we know to get x squared, you have to have x and x. Now 35 is a nice number because there are only two sets of factors, 1 and 35 and 5 and 7. Right? So this method could be used a little more easily in certain instances, right? Now we had so since it's a minus 35, we know we had a plus in one bracket and a minus in the next. How do we know? Whatever sign this has, the larger factor has that sign in front of it. Which one is bigger, 7 or 5? 7. So if this is the plus, that's the minus. Right? Now, of course, if you want to see the full factorization, right? So we know that it's going to split into minus 5 and plus 7. So again, you could put the minus 5 first or the plus 7 first. It does not matter, right? Remember, we're not just doing this step arbitrarily. There's a logic in it, right? We're rewriting 2 as 7 minus 5. And the reason we're doing that is to facilitate the factorization by grouping. As in we factorize in this pair and then this pair, right? Between x squared and 7x, the common factor is x. When we divide or factorize, we're going to get x plus 7. Between minus 5x and minus 35, minus 5 is the common factor. When we divide, you again get x plus 7. You have to divide each term by the common factor, guys. And we notice that the bracket now becomes the common factor. So we have x plus 7 and then x minus 5. What year? This one is in Jan 2025. But I'm picking the algebra from all the years between 2015 and 2025. Yeah. Right. So now we have we have this and we have this. So when they say down here, hence, so again, the keyword here, hence, means using what you just did, right? Simplify that. So the numerator, x squared minus 49, we saw could be simplified by the pink, right? So you can put x plus 7 by x minus 7. And then the quadratic could be factored in the green. So you can put the x plus 7 first and the x minus 5 second, or vice versa, doesn't matter. But when we do this, what we're supposed to see is that this could cancel with that, leaving us with x minus 7 over x minus 5. Right? And that's the simplified version there. All right. Google Meet, just give me a quick G if you're good with this whole question, please and thanks. So that was Judy, Liam, D'Angelo, and Aoife, and Jaden, sorry. I have 3 out of 5. All right. Okay. So now we still have stuff in the questions to do, especially between like 2023 and 2025. They had some slightly different things, right? They like to sometimes couple algebra and quadratics with shapes and concepts like perimeter, area. One of them even had angles. So you had to know some properties of your shapes, like the sum of all the interior angles, right? Pixel 2025, yeah. There you go. Right. So with that, let's just take a quick browse here. So 2015, right? We did all of that already. So that's done. 2016, we did those already. That's done. 2017, we did those. 2018. Oh wait, hold on. We have one here. Sorry, that we didn't do. So let's do it quickly. All right. Now here, this doesn't exactly look like a quadratic, but we could apply the factorization by grouping. Right? We could try it. So let's try to factorize the first pair of terms, then the second pair, and then see if we could factorize again. All right, so I'll give you a couple of minutes to sort that out. Okay, let's see. All right, so between PQ and Q squared. So PQ is P multiplied by Q. Q squared is Q multiplied by Q. So the common factor there is obviously Q. And when you pull it out, what you're going to get in the bracket? P minus Q. Now here, you have minus 3P plus Q. So you have minus 3 by P plus 3 being multiplied by Q. So clearly 3 is the common factor. But what I would suggest is to pull out a minus 3. Because when you pull out the minus 3 and you divide, you're going to get a positive P, right, but a negative Q. All right. So now we have P minus Q as the common factor, and then Q minus 3 as the uncommon. Of course, okay, so that piece there. All right, good job, Shepard. Very good. All right, in class, people, are we okay with that item in the green on the screen there? Yeah? Ziani with us? Sure. All right, did that one already? All right, 23. Okay, let's see what else we had in case we missed anything easy. No. No. All right, there's a nice one to start with. Right, and that'll lead up to the 2024 May. Okay, cool. So we did that one. Let's go back. Let's go back here. All right, this one says factorize completely, right? So let me write that over so it's a bit more, it's a bit clearer. You have 3n squared plus 15np. Right, so I'm going to give you a minute or two to factorize that. And then we'll take a look at the question with the shape below. Right, 3n plus 5 and plus. Yeah, that's correct. Right, okay, so 3n squared. So 3n squared is 3 multiplied by n multiplied by n, right? Now 15. Now seeing as 3 is the number in the first term, what about 15? Can we express 15 as 3 by something? Is how you do it? 3 by 5, right? So we could do 3 by 5 by n by p. So what's common here? 3 and the n. Let's pull that as a common factor. So 3n. When you pull the 3n, what's left? N plus 5p. Graphs messing up, like what transformations or like quadratic graphs or. All right, we okay with that one? Any questions? Anybody? Anything? We will meet, Dr. Mel. Quick G. All right, cool. All right. Now, this one says here, diagram below shows a quadrilateral with the length of its sides written in terms of x. A quadrilateral is a plane figure with 4 sides. Quad, 4 lateral sides. Now, it says, write an expression in terms of x for the perimeter and express your answer in its simplest form. Oh, you mean coordinate geometry? Okay, I did that already. Check out my channel, check out my YouTube. I did coordinate geometry recently. Right, what does perimeter mean? The total distance around, right? So this plus this plus this plus this. So if they want an expression for the perimeter, all you have to do is put P for perimeter is equal to, and you'll put this plus that plus that plus that. All right? Let me start there. So it doesn't matter the sequence in which you put them, right? So you can put 15 minus 2x plus 3x minus 7 plus 2x plus 5 plus 2x minus 1, right? Zoom in. No problem. Yeah, it's a little fuzzy. All right, and then what you'll do is you'll expand. You'll drop the brackets and simplify. So you'll group all the algebra together. You'll group all the integers or constants together and simplify. Hello, evening. Hi. Uh-huh. Yeah, okay, I'll let them know. Okay, good. Yeah, good. Definitely. Okay, cool. Right. Yeah, do that. I'm on just you on the way. Hey Zian. Oh, yeah, how are you doing? All right, so what we have? We have 15 minus 2x. And we have plus 3x minus 7 plus 2x plus 5, and then plus 2x minus 1. Okay, I kind of going off the page here. Huh? No, sorry, yeah, not you. Not you, page. Right. Zana, yeah, that's correct. Okay, so let's group together all the algebra, right? So we have a minus 2x, we have a plus 3x, we have a plus 2x, and our next plus 2x. And for the integers, we have a 15 minus 7 plus 5 minus 1. So minus 2x and plus 2x will cancel. And then you have a 3x plus 2x, which is 5x. 15 minus 7 is 8. 5 minus 1 is 4. And 8 plus 4 is 12. Oh, hello, my beautiful wife. How are you? You good? All right. Right, so the perimeter is equal to 5x minus 7. Now, it says down here, the perimeter of the quadrilateral is equal to 32. You're going? All right. We'll confirm for tomorrow, right? So if the perimeter is equal to that, find the length of the longest side. Now, we don't know which side is the longest side. I would probably guess it's either going to be this one or that one. All right. But the first thing we have to do is find the value of x. So using this equation down here, 5x plus 12 equal to 32, solve for x, and then go back and figure out which of those sides is the longest. Just seen Adma's videos in. Check any lives. Or just search a crochet channel for coordinate geometry. Tomorrow is Tuesday. Wait, is it the same zine on both sides? All right, so I'm gonna just work in the middle of the page here, so I'll just scroll up and down. So if 5x plus 12 is equal to 32, how do we solve for x? So we went through transposition week before. So the first thing we'd have to do is move the 12. How is the 12 attached? Addition. How do we remove something attached by addition? Opposite operations. We're going to subtract 12 from both sides. When you subtract 12 from the left-hand side, it'll cancel with that, leaving us with just 5x. 32 minus 12 is 20. We have to remove the 5. How is the 5 attached? Multiplication. How do we remove something attached by multiplication? We use division. When we divide by 5 here, it'll cancel, leaving us with x. And of course, whatever happens to one side of an equation must happen on the next side. 20 divided by 5 is 4. So x is 4, but you're not done because they're asking what is the length of the longest side. Right? So you have 3 of them. You have 4. You have 15 minus 2 by x. You have 3x minus 7. You have 2x minus 1. And you also have 2x plus 5. Right? So we could probably already eliminate the first one and the third one, but let's work it out. So 2 by 4 is 8. 15 minus 8 is 7. You never know. 3 by 4 is 12. 12 minus 7 is 5. 2 by 4 is 8. 8 minus 1 is also 7. But 2 by 4 is 8, and 8 plus 5 is 13. The longest side is 13 centimeters. Okay, Google Meet, just give me a quick G in the chat if you're good with that. Well, the whole thing, but specifically the one in the green. The wire. Yeah, I am actually. When? I have no clue. I have the solutions already. So it's just to shoot. I haven't sent to edit. That's the problem. I'll see if I could actually I have the PDF already available. Right. Okay. Cool. So Liam and D'Angelo. What about Julian? Like Hanifa digs out. All right, folks. That's about it for today. When we come back on Wednesday, we are going to work the questions like these. right? So we have 1, 2, 3, 4. Yeah, 4 of them to now. It's only 4, but they might take a little while, right? And like I said, after that, we are off. We are off until next week, Tuesday, after the POA exam, right? So again, we're packing in 8 to 10 sessions in about 2 to 3 days. But obviously, if you guys have any exams to study for, like EDPM or French or TD or HSB, do that, right? But I would encourage you to come to at least 1 or 2 maths classes just to keep pace with it, right? Of course, if you can't do that, then you have to come only on Thursday. I'm not sure. Let's take I'll send a poll in the chat. I'll add it to the chat now, and I'll take a poll. What time on Wednesday? 6:30 ish. Huh? I know. I said I'd add you. Yeah. All right. Okay. So folks, that's about it for today. So Google Meet, I'll go on. I'll see you guys on Wednesday. Bye. YouTube, have to join it.